So today we are in lesson 51 and we are going to talk about common logarithms and natural logarithms. So common logarithms and natural logarithms. So we remember that a logarithm is just another way to write an exponent, right? So the answer is the exponent when we write a logarithm. And we have our base, which would be the number that we use with the exponent, and our answer, and then that is going to equal the exponent that would have been used on the base to get that answer. Just look over on this side to see a comparison. 100 is equal to 10 squared is the same thing as the base 10 number that gives you 100 has an exponent of 2. That's what it is saying. So common logarithms have bases of 2 or 10. So if it has a base of 2 or 10, we call that a common logarithm. All right. E is an irrational number that equals 2.7182818 ... It goes on and on. It is a non-repeating, non-terminating decimal. That's what makes it an irrational number. When we use it as a base, we call it a natural logarithm. I don't know why. That is just what we do. A log without a base is a base 10. So log 42 is really the log with the base 10 that equals 42. Ln with no base is equal to the log e. So ln 42 is really the log of base e that is 42. So that is our lesson, all of our lesson for today. You're going to want to take down these notes. We are going to go ahead and jump right into a practice problem. We don't have any other parts of this lesson. We have 5 practice problems. So I'm going to erase this board, write it up here, and then we'll walk through it so we can understand what's going on. All right, here's our first problem. 51.1 says write 2.4 as a power with a base of A, 10, so we'll do that first, and then B with E. So let's practice it with a base of 10 first. So what we're going to do is we are going to enter 2.4 on a scientific calculator, and then we're going to press the log 10 button right here. And this is what it gives us, 0.380. We're going to round everything to 2 decimals when we're dealing with these right now, just for the sake of getting the same answer and getting some understanding on how to do this. So the way that we would write this for A, the answer for A would be 2.4 is equal to the base 10 with 0.38 as the exponent. All right. So you put in 2.4. In the calculator, we would type 2.4, and then we would press the log 10 button, and then that would equal 0.38, yada, 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 yada. We round it to 2 decimals, and then that becomes the exponent that goes up here. All right, this is what's on the calculator. So that is how you would solve a problem like that. Type in the number, hit the log 10 button, and it spits out the exponent for the base of 10, which it's telling you here, log 10, you've got a base of 10. All right. Hopefully your calculator has that log 10. If it doesn't have the log 10, it might just have log. It might just say log, and that's fine. All right, so let's try that for B with the base of E and see what we get. Let's bring up my calculator again over here. All right, so if we enter 2.4 on the calculator and we press the LN key right here, we get a big long number. And we can round this to 8.88. So we would write that like this. We would say 2.4 is equal to E 0.88. So again, the way we would calculate that would be 2.4, and then we would press the ln key, and then that would give us the 0.88, or the number that we rounded to 0.88, which would become our exponent. All right, so that is how you're going to solve these types of problems going forward into the future. Let's do 51.2. Let me write it out for us. All right, so 51.2 says to find A, the log of 2.4, and B, the ln of 2.4. Or I should say the common logarithm 2.4 and the natural logarithm 2.4. So that's the way we want to call that. Common logarithm, natural logarithm. So that's what we're doing for all of these. So log indicates that it's a base 10 exponent. So this is a base 10, and this is going to be a base e. So we have, from the preceding example, from this one, we see that our log 2.4, we have the base 10 with the exponent of 0.38. We can rewrite that like this. So A is going to be written as the log of 2.4, because this is our answer, and our base is 10. It's just, we don't write it. We understand it's like the invisible one. We understand that it's there. And then our exponent is 0.38. So that's how we would write that. We would convert that to this. And then B, the natural logarithm of 2.4, we would rewrite that as ln 2.4, right? So here's our base, here's our base, here's our exponent, that's our exponent, right? This is going to be our answer. So that is going to be, I'm sorry, this is our answer, this is our exponent. So this is going to be 0.88. So if you think about it, if you look at it, the way that we get this answer here, when we convert it over to the log, is almost like it's written. It is almost exactly the way we would put it into the calculator, right? We just reverse the button. So the log with the base 10, where the answer is 2.4, is equal to 0.38. The natural logarithm with the base of e, that is 2.4, is equal to 0.88. I mean, that's what we have here. If you look at it, you just flip these two, and you flip these two, and then you take the 10 off. It's the same thing. All right? So let's look at some different ones. I'm going to look at 51.3. Be sure that you write these example problems down, specifically these two next to each other, because these will show you how to go back and forth between the two. That's going to help you a lot. All right, so let me pause and do 51.3. All right, so 51.3 asks us to write 24,000 as a power with a base of 10. So we write the log, we understand the base of 10 is written there, but it's invisible, and our answer is going to be 24,000. So the way we would solve that on the calculator is type in 24,000, press the log 10 button, and this gives us our answer, and we're going to round it to 2 decimal places. So that would be 4.38. And we are going to write that as a power with a base of 10. So that's going to be 24,000 is the answer, is equal to a base of 10 with 4.38 as the exponent. That's how we do those, okay? So this is like telling you how to put in the calculator, and this is how you would write it as an exponent. All right, let's do one more. All right, in 51.4, we're asked to write 24,000 as a power whose base is e. So that is going to be, if it's e, it's ln, or natural logarithm. Think about, you could call this logarithm natural, if that helps you remember. So you would just type in your calculator 24,000 and press the ln button, and it gives us 10.0858. I'm going to round this up to 10.09. So that's what I would write here, 10.09. And then I would write that as an answer, 24,000 is equal to e with an exponent of 10.09. All right, make sure you put both of these examples down together so that you can see how to switch between the two and how that works. All right, so we type the number in, then we press this key, and that gives us the exponent we need to use to rewrite it with the base of e. Okay, let's do 51.5. All right, our last problem for this lesson says to write 0.0024 as a 10 raised to a power and b e raised to a power. So we rewrite the 10 raised to a power as a base 10, so we use a log. So log of 0.0024 equals, so all we're going to do is we're going to type that in, 0.0024, and press the log 10 button. We get a negative 2.619, so we're going to round that to negative 2.62. And that allows us to write that as 0.0024 is equal to 10 with a negative 2.62 exponent. Now we're going to do the base of e. So again, 0.0024, we hit the ln, or the natural logarithm button, and we get negative 6.03222. We're just going to round that to 6.03. So negative 6.03 allows me to write this as 0.0024 is equal to e with a negative 6.03 exponent. And that would be how you write those. Be sure to put this in your notebook also so that you can see how to do those. And remember, we're typing in the number and then pressing the corresponding button to get the exponent to put on our base that goes with whatever this is. And this is the log 10, and this is the natural log, which is e. So that dictates the base that goes here. So once you see these side by side, then it becomes really easy to know how to do them on the calculator. All right, that's all we have for lesson 51.